Row 1.text, Notepad window, text editor, editing, blank. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just close eyes and listen. Based on G scheme for electronics engineering group. Subject, digital communication, 17,535. These are mostly important questions which is always repeat. Form top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Digital Communication Chapter 3. 1. 2. Explain Shannon-Hartley's theorem with suitable example. ANS, theorem statement with expression, 3 marks, example, 3 marks, the channel capacity of a wide, band-limited Gaussian channel is given by. B. Generate CRC code for data word 110, 110, 1001 by using divisor as 1101. State 2 advantages of CRC method. ANS, correctly solved answer, 4 marks, 2 advantages of CRC, 1 mark each, dividend, 1101101001 divisor, 1101 no of zeros to be added to dividend, 3. D. With example explain how Hamming code is used for single-bit error correction. ANS, explanation with proper example 4 marks, Hamming codes are basically linear block codes. It is in single-bit error correcting code. The parity bits are inserted in between the data bits as shown below. Let the data be 100, 1101. Digital Communication Chapter 3. 2. So the number of parity bits to be added are 4 at transmitter side. Parity bits calculated using even parity transmitted data is 1001, 110, 0101 at receiver side. Let the received data be 10010100101. Again parity bits are calculated. The decimal value of parity bit combination gives us the bit position where the error occurred. Hence the single-bit error can be corrected using Hamming code. Digital Communication Chapter 3. 3. 2. List different types of errors and their causes. ANS, types of errors, 2 marks, any 2 relevant causes of errors, 2 marks, types of errors, 2 marks, the errors introduced in the data bits during their transmission can be categorized as 1. Content errors 2. Flow integrity errors depending on the number of bits in the error, the errors can be classified into 2 types as 1. Single-bit error 2. Burst error causes of errors, any 2 relevant points 2 marks, due to addition of noise in transmission and reception of data following errors occur. 1. If data block is lost in the network as it has been delivered to wrong destination. 2. If 2 or more bits from data unit, such as a byte change from 1 to 0 or 0 to 1. 3. Explain alternate Mark inversion, AMI, coding with suitable example. ANS, define 1 mark, example with waveform, 3 marks. AMI alternate Mark inversion in this line coding a 0 is represented at 0 level, 0V. While alternate 1s are represented at 1V and -1V level as shown with an example AMI waveforms of line codes for data stream 110, 1001 is as shown. B. Encode the following binary data stream into unipolar RZ, unipolar NRZ, polar return 0, RZ, polar NRZ, AMI and split phase Manchester code data stream, 1011 010 01016 MANS. Digital Communication Chapter 3. 4. A. Define line coding. Give the classification of line coding. ANS, definition 01M. Line coding. It is a process of converting binary data, a sequence of bits, to a suitable format for transmission through the channel with minimum probability of errors. Classification. A. Explain the working of CRC generator and checker. 6 MANS, Cyclic Redundancy Check, CRC. With CRC, the entire data stream is treated as long continuous binary number. In this method, a sequence of redundant bits, called the CRC, or the CRC remainder, is appended to the end. Digital Communication Chapter 3. 5. Of the unit so that the resulting data unit becomes exactly divisible by a second, predetermined binary number. At its destination, the incoming data unit is divided by the same number. If at this step there is no remainder, the data unit assumed to be correct, and is accepted, otherwise it indicate that data unit has been damaged in transmission, and therefore must be rejected. The redundancies bits are used by CRC are derived by dividing the data unit by a predetermined divisor. The remainder is the CRC. D. Define the following terms. I. Code word. The second, code rate. 3. Hamming weight. 4. Hamming distance related to code. ANS, code word. 01M. The code word is code consisting of data unit and party bits / redundant bits. Code rate 01M. The code rate is defined as the ratio of the number of message bits, K, to the total number of bits, N, in a code word. Code rate, R, equals Hamming weight 01M. The Hamming weight of a code word X is defined as the number of non-zero element in the code word. Hamming weight of a code vector, code word, is the distance between that code word and an all-zero code vector, a code having all element equal to 0. Digital Communication Chapter 3. 6. Hamming distance related to code 01M. The Hamming distance is the distance between two code word. The bits 2, 4, 8 are different from each other. Hence Hamming distance is 3. D. Why pseudo-noise sequence used in spread spectrum modulation? For MANS, the use of pseudo-noise sequence / codes in spread spectrum modulation makes signals appear wideband and noise-like, because of which the spectrum signal possess 1. A low probability to intercept. 2. Resistance to unintended or intended jamming. 3. Sharing of a signal channel among multiple users is possible. A. Define entropy and state its unit. ANS, definition 2 MKS, 1 MK formula, unit 1 MKS. Entropy is defined as the average number of bits per symbol needed to encode long sequences of symbols emitted by the source. Its unit is bits / symbol mathematically. Where H is entropy, pi is the probabilities of the occurrence of the ith symbol. A discrete memory-less source has the letters A, B, C, and D with corresponding probabilities 0, 0.8, 0.2, 12, 0.4, I. Derive Huffman code for the above source. 2. Determine the average length of the code word. 3. Determine the coding efficiency of the Huffman code design. ANS, Huffman code derivation 4 MKS, average length 1 MKS, coding efficiency 2 MKS, Hamming code. Digital Communication Chapter 3. 7. Average length of code word. Code word efficiency equals H/L equals 1.637/1.4. 117%. Digital Communication Chapter 3. 8. Code word efficiency equals H/L equals 1.637/1.4117%. Note: addition of probabilities is not one for Huffman coding in the given problem. Numerical is solved based on data given, and efficiency ANS is 117% in the solution, but efficiency cannot be more than 100%.